Right now, this chapter is known as experimental techniques. Okay. And before I teach you this, okay, let's go through some of the basics. Okay. Dekho. You have solute. Okay. You have solute. Okay. Now this solute can be of different types. Okay. This solute can be soluble. Okay. This solute can be insoluble. This solute can be magnetic, or this solute can be a colored dye, okay, or a colored substance. Okay, it could be anything. Now, in your syllabus, we have to learn separation technique specifically. Okay, by separation technique, what do we mean? That how we are going to separate it out. Yeah. For example, when we talk about the soluble solute, okay, let's say if I dissolve it in water, okay, so a solution will be formed, right? Okay. And let's say if in the insoluble solute, if I add water, what will be formed? A mixture will be formed. Okay. Remember, chemically uncombined, but physically they're together. Okay. All right. Now, the basic question, which is tested in multiple ways, a very basic technique is questioned every time. And that basic technique is either from the solution, you know how to separate the solute back. Okay. And if you know how to separate the solvent back. Are you getting it? These are the two things they would test you if you are aware of it, how to separate them out. Okay. Now, this solute, let's say if you want to separate out the solute, okay. So, either you can do crystallization, okay, or you can do evaporation till dryness. Got it? Okay. And when we talk about solvent, okay, by the way, what is the mnemonic for crystallization that I taught you? Peter? HCFD. Remember? It's a. H stood for? Very good. Heat till saturation point. C is crystallize. What is crystallize? Okay. Yeah. So that means in crystallization, what are you doing? You have the solution, okay, and you heat it up, okay. You heat it up till a saturated solution is formed, okay. How would you test if saturated solution is formed or not? Very good. Very good. Glass rod. You should know names of these equipments, okay. I'm going to post it. Tell me. I'm going to post it in your GCR, okay. Okay. Now look over here. Glass rod, okay, is used to pick up a droplet, okay, of the solution, and then we are going to take a glass slide, okay, and we'll place with the help of this glass rod, we'll place a droplet over here. If in this droplet, if little tiny crystal go to bed, that means saturated solution has been formed. What is definition of saturated solution? Very good. If you write only this, no more can be dissolved, you'll get, let's say, out of 2, you'll get 1 mark. But if it's of 1 mark, you'll get 0. Why? Because you're not adding the magic word that is at certain temperature. Okay. Because the solubility changes as per the temperature, solubility changes. Okay. So what do we need is we want temperature. Okay. At specific temperature, we are going to check the solubility. Are you getting that? Okay. And afterwards, we are going to keep it aside. Okay. So when we keep it aside, the saturated solution, okay, now we are talking about C, okay? C is Crystallize. Okay, crystallize is by leaving it aside, okay, crystals would be formed. And when crystals are formed, then what do? You wash it with what? Astaghfirullah. Alcohol. If you will wash it with distilled water, it will dissolve back and form this back, right? So, so you will add alcohol to it, wash it up, and then you will filter it out. Filter the crystals. Okay. Now, very good. Okay, and then you dry it between the layers of filter paper. Okay, you got it? What is crystallization? Okay, okay. I think they're there in the notebook as well, no? Crystallization. Only few? No, only those words are there. Check your notebook. Only those notebook, those keywords which are there in your notebook, they will only be coming. It's okay. We can do it later on. Look over here. Now you understand it, huh? Now look over here. Now this drawing, okay, how are you doing it? It also would decide what kind of size of the crystals would be there. If you're drying it up quickly, okay, so the crystals form would be in powder form. Okay, if you'll dry it up quickly. Okay, but let's say if you are leaving it overnight to dry, okay, then very beautiful big crystals would come. Okay, very the very beautiful big crystals would be appearing. Yes, sir. That let's say if you have to separate the solute, okay, so you'll do either crystallization or evaporation in dryness. What is evaporation in dryness? Huh. Okay. So you'll keep on heating it till crystals will appear. Okay. But you don't do that. Why you don't do that? Because sometimes some solutes are heat sensitive. Okay. For example, what are heat sensitive? The heat sensitive ones are, wait a minute. The heat sensitive ones are what? Copper sulfate, sugar. Okay. It's four, okay? It's four. Copper sulfate and sugar. All right. So these are heat sensitive. So what would happen is on heating, they would decompose. Are you getting? They would decompose on heating. You got it? Okay. Now we are talking about solvent. How would you get the solvent back? Okay. Look, you get the solvent back by distillation. Now, distillation, there are two processes by which you do distillation. What are those two processes? No. The processes. Evaporation. Look over here. Evaporation and condensation. Okay, these are the two processes that you do in order to get the solvent back. Okay, and this distillation is of two types. One is simple distillation. Very good. And the other one is fractional distillation. Okay, and you do that on the basis of boiling point. Okay, if the boiling points are very far away, so you'll do simple distillation. Okay, and if the boiling points are very close to each other, so we'll do fractional distillation. वहाँ पर और भी टीचर्स होंगे अच्छा असल में यहाँ पर ये सॉकेट है मतलब यहाँ पर नहीं है क्या अच्छा काम करते हैं जब तक आप लोग की काम करते हैं इस वक्त तक के लिए हम लोग दूसरे रूम में चले जाए हाँ ठीक है फिर हम लोग एक बात ठीक अभी भी खुला है ना पूरी रेस आउट हो जाएगी थैंक यू पूरी रेस आउट हो जाएगी अच्छा बेटा आज चेयर रख के बैठ जाओ तो बाद हम लोग करेंगे अच्छा बेटा ये सब देखो चलो स्टार्ट करते हैं देखो so now you have start okay now look over here so when you're doing this distillation okay there are two types simple distillation and fractional distillation and you do that on the basis of boiling points okay if the boiling points are very far away from each other then you do this simple distillation if the boiling points are very close to each other fractional excellent okay this apparatus is same for both the apparatus is same okay talk about the apparatus of simple distillation okay I'm sure you remember this right huh how do you do that you have thermometer over here let's say okay and then you have round bottom flask right okay once you draw the round bottom flask then you have to be very careful that you have to make the condenser okay like that so that this intersection is where the bulb of the thermometer is there okay then you'll do over here like this okay because sometimes they give you the entire apparatus to draw apart from the condenser and they ask you to draw it okay and then you would place it like that okay and over here let's say you're placing right now a salty solution okay you'll place Bunsen burner over here. Okay. And once you heat it, okay, what will happen? The water would evaporate first of all. Okay, why? Because salt has, let's say, a very high boiling point. Okay, let's say it has 1,000 degrees Celsius. Okay, and water, it has 100 degrees Celsius boiling point. So the boiling points are very far away from each other. So water would be the first one to evaporate. Okay, and then what would happen in the condenser? Okay, very good. Why? Why? What is the logic? Okay, look over here. So condenser acts as a colder surface. Okay, so when water vapors would touch this colder surface, they would lose heat. The particles will get closer, and when the particles get closer, what reduces? Intermolecular spaces. Remember, intermolecular spaces would reduce and the gas would become liquid. Simple. Okay, the gas will become liquid. Okay. Now, another very tricky question to ask you is how to, like, from which end water would get in and from which end water would get out. Okay. So you have to remember water would get in from here. Okay. And water would get out from here. Why is that so? What is the logic? Because you have to keep vapor direction. Okay, you have to keep vapor direction and water direction in different ways. Okay, in different directions. Why? In order to maintain concentration, in order to maintain temperature difference. Okay, why is it opposite flow? Like you see, the vapors are flowing from here to here, right? Okay, the water is getting in and it is flowing from here to here, right? Why is that so? Because we have to maintain the temperature difference. Okay, and now when vapors would come over here, okay, they would condense, droplets of water would form, okay, and then in this beaker, the droplets would be collected and this would be called as distillate. Okay, this is distillate. Okay, you get it? Then you can make this thing turn up into fractional distillation as well. The same apparatus. You just have to add one thing. What is that one thing? What is the same? If you want to make this simple distillation turn up into fractional distillation, then you have to add fractionating. Thank you. Okay. So this is called fractionating column. Okay. And in fractionating column, okay. So what we did, we had simple distillation over here, right? Simple distillation apparatus. We added fractionating column to make it turn up into fractional distillation. Exactly. Okay. And when do you do? Now let's say instead of salty solution, I have alcohol and water solution. Okay. Alcohol boils off at 78 degrees Celsius. Okay. Alcohol boils off at 78 degrees Celsius. Water boils off at 700 degrees Celsius. Okay. So what would be the first thing that would evaporate? Alcohol. Alcohol would be the first thing to evaporate. Okay. What are these over here? This is glass bead, right? Okay. So glass bead would act as a colder surface. And let's say glass bead's temperature is 78 degrees Celsius at the moment. And if, let's just imagine that if, let's say, some water molecule escaped, okay, so what would happen? It would touch the glass bead, which is 78 degrees Celsius. It would condense, okay. It would touch the glass bead, okay, which would act as a colder surface. It would condense and it would drip back. Okay, so that's how alcohol would be separated from the water. Okay, are you getting? So alcohol would evaporate, like it would evaporate, it would go over here, it would condense into droplets, okay, and it would be collected over here as distillate. You got it? Okay. Achha. Then we are doing, okay, a quick summary. Okay? You have solution. Out of solution, if you want solute, so how would you separate it? By crystallization or evaporation till dryness. HCl. Okay. And if you want to separate out by distillation, if you want to separate out solvent, so you'll do it by distillation. Distillation can be done by two ways, simple and fractional distillation, depending on the boiling point. If the boiling point is closer, you do fractional distillation. If the boiling points are far away from each other, you do simple distillation. Okay. There are two steps in which distillation happens. First is evaporation, and second one is condensation. Excellent. Now we would learn this thing. Okay. And since we don't have much space over here, okay, we are going to utilize this space over here. Okay. So let's just say now we are going to talk about that out of the mixture. Okay. How would you separate out what and what? Solute again, which is insoluble, and the solvent. It's very simple actually. Why? Because you'll do both by one process, and that is filtration. Is filtration spelling correct? Are you sure? No, there is no E over here. Okay. No, E nahi hai. There's no E over here at all. Never, ever. You can Google it. Yeah. Okay. It's TRA. Okay. Okay, listen. So let's just say I have a beaker, all right, in which I have, let's say, copper mixed up with copper sulfate solution. Okay. So now copper are the granules. Okay. Copper, copper in copper sulfate solution. Okay. So copper is solid because all metals are solid except mercury. Excellent. Okay. So you have copper sulfate solution. Now what do? You're going to filter it out. Okay. When you're going to filter it out, so what will you get over here? On the, no, on over here, on top of the filter paper, copper particles. This is how I wanted you to talk. Okay. So you should know that on top of the filter paper, you're going to get copper in the solid state. What would you call this copper in solid state right now? Residue. Excellent. Okay, residue is anything that is left behind. Okay, all right. And then over here would be the solvent. Okay, this is what? This is the solute that you have separated already, right? This was the solute. Okay, and how are you going to separate the solvent? You're going to separate the solvent also by filtration. Okay, and filtration, after filtration, this liquid that you have collected, the solvent that you have collected, this is called what? Filtrate. Are you getting? So this is how you'll get it out. Now, what will you do with the residue? Forward. You'll do forward. What is forward? You'll, after filtering, okay, you will filter it. After that, you will wash it. Wash. Alcohol would dissolve it away, probably. With distilled water, very good. With distilled water. So now you understand all of the salts or crystals, okay, or soluble solute, you're going to wash with alcohol. And all of the insoluble, all of the solute, which is soluble, okay, you're going to wash it with alcohol. And all of the solutes which are insoluble, you are going to wash it with distilled water. Why not with tap water? Tap water has a lot of impurities in it. Okay. Then you do these. These what? Dry between the layers of filter paper. Always these dry between the layers of filter paper. You got it to here? Okay. Now, how would you separate the particles which are magnetic? With the help of magnet. Okay. And how are you going to separate out the colored particles? Color substances? Excellent. Excellent. Chromatography. Uh-huh. Do you want a quick revision of chromatography? Start. Okay, so now we are doing quick revision of chromatography. Okay, in chromatography, what do we do? First of all, we prepare the chromatography paper. Okay, so what do? We first of all have chromatography paper. We draw the baseline over here. Okay, and we draw baseline with pencil. This is very important that we draw the baseline with pencil. आप एक काम करें जी वालों को बिठा दें है ना Okay, fine. So we are doing chromatography at the moment, okay? So we have chromatography paper, all right, in which we place first of all a baseline, all right, and that baseline we drew with pencil, okay? And then we place solute to be tested over here, okay? Then we place it in the beaker and we made it sure that the baseline is above the solvent level, okay? The other thing that we have to make sure is that this solvent can actually dissolve this solute. Why? Because chromatography happens on the basis of solubility. Okay, are you getting that? Okay, so chromatography happens on the basis of solubility. Okay, we have first of all the paper, We place the baseline with pencil. We place the solid spot over here. Okay, we do not draw it with ink. Why? How would you talk about that in English? That the dyes would separate and it would interfere with the result. Okay. How would you talk about it? That the result. Okay. Now look over here. So as the solvent will go up, okay, this solute would also go up. Okay, and it would break down into different solute spots. Okay, and water would reach till here, okay, and this would be known as solvent frontal where the water has reached. Okay, and these solute spots you will then like you will just take it out and you'll dry it. Okay, and then what do you do in order to identify these solutes? You calculate the RF value. Okay, what is the okay. Okay. All right, you don't have to do this cohesion and addition thing. Okay, don't worry about that. Okay. Now look over here. Now look over here. This is the correct way to do it, right? Okay. And this is also the correct way to do it. Okay. So let's say there is just one solute spot which is climbing up. Okay. And let's say if you have three different solute spots, you can plan it up like that, and these solute spots will climb up. Right. Okay. But imagine over here you have drawn with ink the baselines. Now, along with the ink dyes would also mix up and interfered with the result. Okay, beta. So now look over here. We have drawn the baseline with pen, okay, which is why the dye has merged with the solutes. Okay. Now look over here. Okay. So over here, you see these are the different results. Okay. So for example, you had a crime scene, okay, and you had detected that this was the dye, okay, which the murderer used. Okay. So you took it over here as a sample, and then you place dye of different people's inks, let's say, different students' ink pots, okay, or different people's ink pots. Okay, you took the dyes and then you use them over here like that. Okay. Wait a minute. You suspected different people, let's say they were A, B, C, D, E, F, okay, and now you wanted to know whose dye, whose pen inks would it possibly be. Okay, yeah. So it matches clearly with E. So E is a suspect. He is arrested. Okay. All right. But now if you look over here, you see what happens is that this person's like we got no solute over here. Why is that?
Because she didn't create
No, no, because he used the ink. No, ink spot is there. Okay. He used the ink, okay, which is insoluble in the solvent. Okay. Yeah, so it won't move up at all. Just imagine what if his ink with alcohol would look like this. Anyways, now,
पेपर में कभी कभी ऐसा भी आ जाता है कि एक पेपर में काफी दिए होते हैं हो जाता है और वो कभी कभी एनालिसिस कुछ कहते हैं कि कौन सी सेम लाइन पे हम ये में
हाँ ये चीज है ठीक है okay now this is just the theory of chromatography okay look over here this is how we did it okay all right you don't have to go into the mobile phase or stationary phase okay these terminologies are not there in your syllabus okay distinguishing pure from impure substances okay how do you do that look for example if I have this brown ink okay this brown ink is made up of three dyes. Okay, so once you do its chromatography, now you can deduce that it had red dye, also the yellow dye, also the brown dye. Okay, are you getting? In your paper, obviously these spots would be black in color. Okay, and then it would be the challenge. Okay, because then this spot you have to match up with this one, and then you have to read. Okay, fine, it's a red dye. They have separated. Then they would look out for the other solute spot, okay, and then they'll match it with this, and they'll say, okay, fine, it's a yellow color dye, we got it, okay. And then they'll match the blue one with this one, and they say, okay, fine, the blue dye is also there. Are you getting? Okay. Now you're identifying substances using the RF values. Okay. What is the RF value? Retardation factor or retention factor. Okay. And what is the formula? It is distance moved by substance divided by distance moved by solvent. Yeah. Okay. Now look, it has no units and its value will always be less than 1. Okay. How would you remember that substance comes on top and solvent comes later? Because in the beaker also, you have solvent at the bottom and substance or solute is at the top, right? Okay. So by that, remember that substance is on top and solvent is down there as denominator.
One of the
Yes, you have to. Solvent, you will check the solvent front. The solvent front is this one on top. Yeah. Yeah. Okay. All right. You've done it in your notebook now. Okay. Huh. So for example, look over here. You have the baseline over here. Okay. This is the solute. Okay. And it will move till here and this is the solvent front. So first of all, from this baseline, look over here very carefully. Okay. That baseline has 0 on it. Okay. All right. And then you measure this for solute which has moved on. Okay. This is 3. And baseline till solvent front, it is 6 centimeter. Okay. Centimeters will centimeter would be cut up by centimeter. Right. So we have no unit over here. 3 divided by 6 is 0.5. Are you getting that? Okay. Now, once you have got the RF value, you will compare it with the known data. Okay, and that's how you get to know that okay, fine, this is solute, this is this type of solvent. You got it?